So if you guys could go to the slide that says a tale of two fluids, I want to share something else that you can do with this hydrostatic pressure equation. Okay, so there's something called a manometer, and it is a tube that is partially filled with water and partially filled with some other material that probably has a different density. Okay, so oil, which does not mix with water, is poured into the left arm of the tube until the oil-water interface is at the midpoint of the tube as shown. Both arms of the tube are open to the air. Find a relationship between these two heights. Okay, I am going to argue that once we find a relationship with these heights, we can use this manometer to be able to find the density of other fluids, as long as we know the density of water. And I'm going to show you how that is in a second. Okay, so the manometer looks something like this. We have basically this U-shaped situation, right? And there's two different fluids. One is the water that's over here. And so that has a certain height, right? And we're going to call that the height W for the height of the water. Okay. And then we have another fluid over here. It's a little bit higher. Okay. And this is going to be the height of the oil, right? This is water. And this over here is oil. Okay? And so we want to find a relationship between these two heights. Okay? All right. So here's the thing. We know that the pressure here is given by this P0 plus rho GH. Okay? But we also know that if these guys meet right here and one isn't dominating the other, okay, we know that the pressure there must be the same, right? Because remember, pressure is just force per area. This is the same area, right? So it must mean the forces are the same. Otherwise, this would be accelerating this way or this would be accelerating this way. And if the forces are the same, the pressure must be the same, right? So we can say that right there, we can say that the pressure of the water is equal to the pressure of the oil. Okay? Okay. So now, this means that we could just take this equation in and put it in there for the pressure of the water. So that's P0, the atmospheric pressure at the top, right? Plus the density of water times G times HW, the height of the water, right? This equation here, that is the pressure of the water right there. But that has to equal the pressure of the oil, right? So what is the pressure of the oil there? Well, again, it's P0, the atmospheric pressure, plus now the density of the oil times gravity times the height of the oil. Here's two cool things that happen. First, the P0 is the atmospheric pressure. That's atmospheric pressure for both of these guys at the top, so that cancels out, right? That means that it's just this little equation here equals this little equation over here, right? So what does that mean? Well, that means that I have these two G's that can easily cancel out now. So the G's go away. See you later, G's, right? That leaves me with rho, the density of water, times the height of the water, must equal the density of the oil times the height of the oil, right? And now we have a relationship that links the height of the water with the height of the oil, okay? Which means that I can find the density of the oil, right, by just solving for rho 0. So if I just go ahead and solve this, I am going to get that the density of the oil equals the density of the water times the height of the water divided by the height of the oil. So what does this really mean? It means that we have now invented a powerful little tool that can find the density of any fluid as long as it doesn't mix with water, right? And the way you would do it is you just find, you put in that other fluid, you find out the height, right? You find out the density of water, which you know it's 1,000 kilograms per meters cubed, and you measure the height of the water as well, and we can find the density of that other material. Okay, so you're going to find that there's many, many ways in which the physics of fluids have been used to create interesting tools that either help us find properties of different matter or are really cool tools that help us do stuff in the world. And we're going to be seeing that in the upcoming videos. I'll see you there.